Do you need high-resolution climate data for your geospatial analysis? In this quick tutorial, I'll show you how to efficiently download climate data using the cDownload function from the KrigR package. Whether you need temperature, precipitation, or other climate variables, this function makes data retrieval so easy. So, the first step here is to load the KrigR package. This is a package for downloading, preprocessing, and statistically downscaling the data of the European Center for Medium-Range Weather Forecast reanalysis, the ERA5 family data. This is provided by the European Center for Medium-Range Weather Forecast. This package interfaces with the Climate Data Store, which is hosted by the Copernicus Climate Change Services. We also need SF library to handle spatial data, of course tidyverse, and the library GeoBoundaries. Our GeoBoundaries is for getting the boundary of the study area. So for today, the boundaries we need is for the region of Edmonton, which is somewhere in Canada. To use the KrigR package, you need to create an account on the CSD Climate Copernicus website. Once you have done this, you can go into your profile to get your API token. You can just copy and paste your API token here and your key here. I'm just sourcing the file which contain those two variables just here. So, this KrigR package gives us access to 3 main datasets. In each one of these datasets, we have some kind of variation of the climate data. The one that we will look at today is the reanalysis RLM monthly mean. If we take a quick look at it, we can see that the dataset is named reanalysis RFI length monthly mean. We have mainly 2 types of data: the monthly average reanalysis and the monthly average reanalysis by hour of the day. One quick interesting thing that I want to point you here is that this data has been regridded to a regular latitude-longitude grid of 0.1 degree by 0.1 degree, which is really interesting when you want high-resolution climate data. If you want to go and take a look at all the variables that are available to us, we need to take a view here of this bar TF data frame. I wanted to take a moment to show this data frame to you just here because in this you have 50 different kind of climate information that you can extract. You'll have the name of the variable just here and the name that you need to use in the function to extract the information you need. You also have a description of the variable if you need a little more information. Today, we're gonna focus principally on total precipitation. So, the last thing we need to do before downloading our data is to set a specific start date, which for us will be the 1st of November of 2023, and an end date, which will be the last day of December of the same year. Okay, the main function here for us today is this cDownload from the KrigR package. I'll show you previously all the name or all the information you need because we need to specify all this information in this specific function. So, if you remember, we need the type, which was just here. So we set the dataset to reanalysis era 5 length monthly mean. And in this dataset, we need the type of data, which is monthly average reanalysis. The variable that I want to look at is total precipitation. Here we need to specify our start date and our end date, plus a little time zone specification. We need to set for me ET. This is just something that helps the function understand the format of the date that I have specified. For the total precipitation, I need the mean and I need the monthly mean. So I want one value of precipitation for every month, and I want this value to be a mean. I need to specify also where I want the function C download to save the data on my hard drive. And the result of this function will be put in a file that's named Precipitation Raw in my data folder. I also need to specify the boundaries or the extent that I want this data for. So here, if you remember, I specify a boundary dataset which contains a polygon for Edmonton. And lastly, I need to specify my API user, my API key, and to clone the connection. If we run this function, takes a minute, and keep in mind that this is an API that doesn't work every time, that doesn't work the first time you use it. And for me here, I have a warning messages telling me that the job is already done. So here we have the second layers of my precipitation raw dataset is composed of a raster data in which each cell of 0.1 degree by 0.1 degree represented a value of the mean of precipitation. Just to show you here, my spatial raster contains 2 layers, one for November and one for December. Now, you're ready to start manipulate this raster. And that's it. You know how to easily download high-resolution climate data using the KrigR package. If you have any question or need help with your own dataset, drop a comment below. I'll be happy to help. Happy coding!